Earth is breaking apart beneath Iceland, and it's happening right now. Every year, the ground here pulls itself open by several centimeters. Not in an earthquake, not in a single explosion, but slowly, silently, and without warning. This movement has built more than 130 active volcanic systems, all sitting beneath towns, power plants, and critical infrastructure. When one of these systems erupts, lava doesn't just spill out. It floods the land at over 1,100 degrees Celsius, burning everything in its path. For decades, the rule was simple. Lava cannot be stopped. You evacuate and hope for the best. But in the past 2 years, Iceland tried something different. Instead of running, engineers built walls directly in the path of molten rock, racing against time, heat, and the Earth itself. The question is no longer if lava can destroy a town. The question is whether humans can slow it down long enough to survive. Please take a moment to subscribe and like the video. It really helps the channel. To understand the scale of the challenge, we have to look at the floor of the Atlantic Ocean. Iceland sits directly atop the mid-Atlantic ridge, the boundary where the North American and Eurasian tectonic plates are diverging. As these plates pull apart, magma from deep within the mantle rises to fill the gap. This continuous upwelling makes volcanic eruptions a routine part of Icelandic life, with an average of 4 significant events occurring every year. Historically, most of these flows reached uninhabited basalt fields, causing little more than a spectacular light show for photographers. However, the geography of risk is changing. With population centers expanding and vital infrastructure becoming more complex, the margin for error has disappeared. There is no reliable system to predict exactly where the next fissure will open, leaving engineers in a permanent race against the ground beneath their feet. The stakes reached a breaking point during the eruptions of 2023 and 2024. A massive fissure opened, spreading lava across approximately 15 square kilometers. The flow was moving directly toward populated zones and, more critically, toward a geothermal power plant that provides heat and electricity to tens of thousands of people. In a subarctic climate, the failure of this plant would be catastrophic, impacting national energy security and daily life on a massive scale. This wasn't just about saving a few houses, it was about preventing a regional collapse. With the lava advancing, Iceland had only one realistic option: they had to build. Iceland launched one of its largest-scale civil engineering operations in history, but the objective wasn't to extinguish the fire. You cannot put out a lava flow. Instead, the goal was to slow and redirect it. This led to the rapid deployment of lava barriers, massive earthen embankments designed to stand in the way of the molten tide. Unlike traditional construction projects that happen in controlled environments, these walls were built while the eruption was still active. Engineers worked in a landscape of toxic gases and extreme heat, dumping millions of tons of earth to create a buffer between the town and the encroaching heat. The scale of this emergency defense is staggering. At their peak, the barriers reached a height of 20 meters. Over the course of 6 months, crews moved more than 3 million cubic meters of material. To put that in perspective, that is enough rock and soil to fill over 1,200 Olympic-sized swimming pools. The walls were constructed almost entirely from local volcanic rock and soil, using the very land the volcano created to defend against it. However, the battle was never easy. In multiple locations, the lava grew so deep that it overtopped the walls, forcing crews to engage in emergency water cooling to harden the flow's leading edge and reinforce the man-made dams. It might seem counterintuitive to fight liquid fire with a pile of dirt, but lava behaves differently than water. It is extremely viscous, meaning it moves slowly and tends to flow along the surface, dictated by slope and elevation. Because lava doesn't exert the same hydrostatic pressure as a deep reservoir of water, these barriers don't require deep, reinforced foundations. Instead, they are constructed in 1-meter vertical layers. As the lava pools against the wall, it begins to cool and solidify, effectively becoming part of the barrier itself. These walls are raised progressively, buying minutes and hours until the eruption naturally subsides, or the flow finds a new path of least resistance. This was a race of speed over aesthetics. Iceland deployed one of the largest emergency earth-moving fleets in its history. Massive machines including the Komatsu D-375, the Liebherr R-976, and the legendary Caterpillar D-11 were pushed to their limits. Alongside them, large articulated dump trucks worked in a continuous loop. Every hour lost to a mechanical failure or a shift change allowed the lava to advance several meters closer to the power plant. The strategy was simple: break the rock, move the rock, and pack it down before the heat became unbearable for the operators. In a poetic twist of engineering, the best material to fight new lava is old lava. Construction crews began by harvesting solidified basalt from eruptions that occurred centuries ago. Basalt is incredibly dense and heavy, making it the perfect weight to hold back a moving flow. Using heavy-duty ripper teeth, bulldozers fractured the ancient rock, which was then transported and compacted into layers. By utilizing the existing geology, engineers created a defense system that was chemically and physically prepared to withstand the thermal shock of the molten rock. What once destroyed the landscape was now being used to preserve it. Despite the heroic efforts, engineering has its limits. During the Reykjanes eruption in 2024, the lava found ways to bypass the defenses. It breached the barriers by opening new fissures directly behind the walls, or by sliding across paved road surfaces where there was less friction to slow it down. These moments serve as a humbling reminder. In a fast-moving volcanic scenario, technology and machinery often cannot move fast enough to outpace the Earth's internal pressure. When barriers fail, history shows that humans turn to more extreme measures. In 1935 and 1942, the United States military attempted to stop lava flows from Mauna Loa in Hawaii by dropping 600-pound bombs from aircraft. The goal was to collapse the lava tubes, the underground pipes that allow molten rock to travel long distances without cooling. The results were inconsistent at best. While some flows slowed briefly, others were completely unaffected. It was a demonstration of desperation, proving that even our most powerful weapons are often no match for a planetary-scale event. However, there is one famous success story. During the 1973 Eldfell eruption on the island of Hime, lava threatened to close off a critical harbor that was the lifeblood of the local economy. In a bold move, Icelanders used high-pressure pumps to spray massive volumes of seawater directly onto the advancing lava front. The water cooled the surface instantly, creating a hardened crust of rock that acted as a natural dam. This forced the molten interior to change direction, ultimately saving the harbor. It didn't stop the volcano, but it proved that with enough water and enough will, we can nudge the path of destruction. Once the heat fades and the rock cools, the story doesn't end. Lava leaves behind a legacy of mineral-rich soil packed with potassium, magnesium, and iron. In volcanic regions around the world, this death actually brings new life. On slopes between 400 and 800 meters, farmers have learned to plant vineyards in the porous volcanic rock. The harsh environment forces roots to grow deeper, seeking moisture and nutrients, which results in a stronger vine and a unique mineral profile in the fruit. The very material that threatened to destroy civilization becomes the foundation for its agriculture. Farming on a volcano is its own form of engineering. Vines are planted at depths of 40 centimeters into a mixture of compost and volcanic ash. It takes about 3 years for the first harvest, but the results are world-class. The dark rock absorbs heat during the day and releases it at night, protecting the plants from frost and optimizing sugar production. This transformation of a hazard into an economic asset shows the resilience of those who live in the shadow of the vents. Ultimately, Iceland's strategy isn't about conquering nature. It's about adaptation. They have learned to see lava not just as a hazard, but as an infrastructure provider. The basalt layers act as natural filters for geothermal water, creating unique ecosystems like the Blue Lagoon, and providing the heat that warms every home in the country. Lava is an energy source, a building material, and a foundation for life. Lava barriers never promise absolute safety. They offer seconds, hours, or perhaps a few months. But in the world of emergency management, those moments are everything. They are the difference between a controlled evacuation and a tragedy, or between a functioning power grid and a national blackout. When the lava finally cools, life in Iceland does not return to exactly how it was before. It returns better adapted, more aware of the scale of our planet, and ready to build again. We cannot defeat the lava, but through engineering and courage, we can learn to live alongside it. Lava cannot be defeated, only redirected, reminding us that humanity's true strength lies not in control, but in adaptation. Thanks for watching Unthinkable Build. We'll see you in the next one.